Artemis II is a program of NASA that is going to take humans to the moon. Now, how long will it take for this particular program or space mission to reach the moon? What happens next? What is the significance of this particular mission? And what other mission will be happening after this? This and much more is what we will discuss in this video. With respect to the prelims, we'll understand how you should study any space mission, what are the things that are important for you to study, and what can be asked in the exam. So let us get started with the news. So the news is about the Artemis II, which has been successfully launched. So the launch has been successful, and that is done by NASA. Now, this particular mission is the first crewed mission beyond the low Earth orbit since 1972. So is this for the very first time? No, it's not for the first time, but since 1972 it is the first one, is what is being said. Now, this is the news all about. We'll understand what this mission specifically does, what the future holds, the timeline of the mission, so on and so forth. But before that, very important as to what you should study for prelims with respect to any space mission. The very first thing is, whatever the name of the space mission, with respect to that, whatever is its objective. In fact, objective becomes a bit detailed. So what it is all about, or with respect to what it is, which planet, you can say which planet is it is studying sometimes, or it is for the moon, or it is for low Earth orbit. For whatever it is, what it is all about is what you should know. That is the most important thing. Second, what is the objective of it? That is also important. Third, who has launched it? Is it NASA? Is it ISRO? Is it a joint combination of various organizations? These three things are the most important. Then subsequently in that, certain features of the mission becomes important, and so this is very important for your prelims. In addition to that, the specific technology etc which might be used in that mission becomes important for your science and tech and other questions. The concept of low Earth orbit becomes important, right? So these are the things that are important. There can be certain things with respect to the weight, this, that. Now, weight is not important for you to exactly remember, but at least you should remember the tentative height, the tentative weight that is there, because UPSC in 2016 has asked questions has asked a question with respect to the weight, wherein they do give you easy option. If the weight is 1000, they are going to mention 10,000 instead of 1000. So just the range roundabout, if you also remember, should be good enough. Now, this is how you should study any mission related to space. So let's continue with this particular mission. Now, the launch vehicle used for this is named as the Space Launch System. It's a very generic name, is given to any launch vehicle which launches certain thing in the space. This vehicle or this launcher was with the Orion crew capsule. Now, what is this crew capsule? This is the capsule, this is the space, this is the place where the crew which is going, a crew of 4 members which is going, they are going to live inside this capsule when they reach over there. What is the duration of the mission? The duration is about 10 days. The objective was to, what was the objective? As I said, objective is also important. Crewed lunar flyby. Crewed lunar flyby, but no landing. That means the crew is not going to land on the moon, but it is going to fly by the moon. So you will have, let's say this is the Earth and this is the moon over here. They are going to reach over here, fly by, and then return. So this around the moon, the distance that they cover is known as the flyby, because they are flying by the side of the moon. That is what they will do. And remember, there is no landing involved over here. Now, what is the significance of this particular project or mission? It talks about the revival of human deep space exploration. Human deep space exploration means, see, you do have space station, but that space station is in the low Earth orbit. It is not in deep space. But here you are sending the crew, that is humans, to deep space. So it is going to sort of revive these missions. Now other countries, USA itself will do more, other countries will also be, you know, doing it, not out of jealousy and stuff, but what happens when someone gets successful, there is more, you know, incentive, or let's say you understand that it is possible, so more confidence, a lot of reasons that are there. And of course the space mission race can also definitely start, right? So it is basically the first steps towards sustainable presence of human on the moon. The test crews safety is going to be important, of course. Life support, deep space navigation, when you are sending humans, all these things you can study, right? The human body, when it is there, how it reacts, all those things can be studied, and it gives us a great detail of insights. Now let us understand what is the objectives of the mission in detail. First is to validate the Orion spacecraft system with the presence of human. So this is the objective, to testify that the Orion spacecraft with the humans on board is basically capable. So it will validate that. It will demonstrate free return trajectory capability. Free return trajectory capability. Not just going, of course coming back. See, what happens is, if you send a mission which does not have human, you are going to send it for flyby, for experiments, etc. You keep on getting the data, and at the end, even if it does not come back, that's not a problem. It will be like a debris in the satellite, and that is the end of the story. But here you have humans, you are going to get them back, so it will be talking about the return as well. Testing of deep space habitation conditions. Can humans survive? Habitation is with respect to the living beings, of course, specifically human beings. And prepare for the future lunar landing mission. This mission is going to prepare the world, specifically here NASA, for the future landing operations. Now, the crew members, if you look at it, it is being said that there is a diversity of crew members. Fair enough. So these four are the crew members. Basically, for the very first time, a black astronaut is going. For the very first time, a female is going to have a flyby for near the moon. These are their names. Names as such, yes, you can maybe remember, at least by looking at the option, you should be able to identify that these people are related with this particular mission. That much you should definitely remember. Now, next is the concept of the trajectory and key other concepts. So this is the trans-lunar injection. This is the trajectory that will be there. If you look at during the launch, the green one is the launch trajectory, and it goes here. This is basically the flyby area wherein it is flying by the moon, and the green one, in fact the flyby starts even way before. If you look at this flyby, the flyby starts here, somewhere here. So this is the trajectory, this is the launch. So yes, the flyby has started here. This is entire flyby. Now here, since the blue starts, so the return has started. This will also be a part of the flyby, and then it is going to come back over here. Okay. The trajectory is free return trajectory. That means it's a natural path looping around the moon and back to Earth. Natural path. If you are like over here and coming back, it's going to naturally push you in this particular side. When you have the natural path, the energy required also is actually lesser. That is the idea over here. Now, the closest lunar approach, the closest that this flyby mission is going to be to the moon is basically 6,450 to 9,650 kilometers above its surface. Right. Mission timeline, if you look at it, it's a 10-day mission. So day one, high Earth orbit plus system checks. So here, when there was high Earth orbit which is taking place, it's not just orbiting. Why it is orbiting so many times? Cannot it directly go? The idea is to orbit, to keep a check, to understand that we are ready to go. Systems can be checked that if everything is functioning well at this level also, so as to then push them later on. Day 3 and 4, the translunar transit will take place. Day 5, entry into moon's gravitational force. Then day 6, the lunar flyby, the flyby which is starting over here. And 7-9 is the return journey and experiments, whatever experiments they would want to conduct over there in that situation. And then re-entry plus specific Pacific splashdown. It's Pacific Ocean where this is going to land back and the people will be then retrieved. Now the technological features, if you look at, see, this is the capsule under which, or inside which I should rather say, these crew members will be inside it. So you have the Space Launch System, which we discussed. Orion capsule, this is the deep space crew vehicle through which they are going to go in the deep space. Advanced heat shield and life support system, heat shield, or because else it can burn. Flight termination system, this is a safety mechanism that is there. It terminate the flight midway in order to return back. Speed during the re-entry would be around 40,000 kilometers per hour. Now, what is the future? So we have understood this particular Artemis II. So what is the future of it? Future probably holds Artemis III in 2027, which is a planned human landing on Mars. Right, so this is the plan. Plus you have lunar landers, that is SpaceX, Blue Origin, all these organizations. Also long-term goal is what? To establish lunar base. So moon can be our base, and from there subsequent things can be launched. It can be getaway to Mars mission and expand our space economy as well. Thank you.